This video will review safety datasheets, explaining the main sections and how to use the datasheet to identify important pollution prevention concepts such as, is it a volatile organic compound? Is it a hazardous air pollutant? Can I find a product with a lower VOC or HAP content? What is the best way to store the product to extend its useful life and prevent spills, contamination, and waste? First, let's talk about what an SDS is and what information it provides. The Safety Datasheet, or SDS, is a document provided by manufacturers, importers, or distributors of a hazardous chemical to downstream users. In 2015, the Global Harmonization System required all SDS to adhere to a specific format. The SDS format is designed to deliver consistent information about the chemical to ensure all users or handlers have the necessary hazard information to safely use, handle, and store the chemical. An SDS will include information such as the properties of each chemical, the physical health and environmental health hazards, protective measures and safety measures for handling, storing, and transporting. An SDS is made up of 16 sections. Because there are several sections in an SDS, it is helpful to break them out into segments for quick navigation. All employers are required to maintain SDSs for chemicals used and stored on site. An EDS is a document that gives information in regards to environmental considerations such as air quality, water quality, and toxic waste disposal. If a manufacturer supplies an EDS, there is a good chance it will have the HAP and VOC information you need. At this time, EDSs are not required to be formatted under the Global Harmonization System, however, are a good companion document to your SDS documents. Sections 1 through 8 provide general information about the chemical, identification, hazards, composition, emergency control measures, and safe handling practices. These sections will be useful to those who need to get the information quickly if an incident occurs. Sections 9 through 11 and 16 contain more technical and scientific information, including physical and chemical properties, stability and reactivity information, toxicological information, and other information such as the date of preparation or last revision. An SDS must also contain sections 12 through 15 to be consistent with the UN Globally Harmonized System of Classification and Labeling of Chemicals. Sections 12 through 15 are not enforced by the Occupational Safety and Health Administration like the other sections of an SDS. Sections 12 through 15 are enforced by other agencies depending on the content of the section. For example, Section 14, Transport Information, details classification information for shipping and transporting hazardous chemicals by road, air, rail, or sea, which would be enforced by the Department of Transportation. Other sections include ecological information, disposal information, and regulatory information. Now let's identify a few sections containing information useful to preventing pollution. Section 1, Identification, has important information to identify the chemical on the SDS and supplier information. This section also details the recommended use of the chemical and any restrictions on its use. Section 2, Hazardous Identification, identifies the hazards of the chemical and appropriate warning information associated with those hazards. Section 2 also provides guidance on general use, prevention, response, storage, and disposal of the chemical. Section 3, Composition and Ingredient Information, contains important details identifying the ingredients contained in the product, including impurities and stabilizing additives. Section 3 will be useful when identifying possible volatile organic compounds, or VOCs, and hazardous air pollutants, known as HAPs, in the product. The section also lists the composition of the product and the chemical abstract service number. Using the CAS number, you can consult if any ingredient is considered a VOC or a HAP. Note that the ingredient name might vary under the same CAS number, so it is important to use the CAS number as reference. Section 9, Physical and Chemical Properties, describes the overall characteristics of the chemical, including aspects to identify air pollutants, vapor density, and relative density. Knowing that water density is 8.345 pounds per US gallon, we can use the provided relative density of 0.86 to calculate the chemical's density at 7.1767 pounds per US gallon. Information included in an SDS can be used to calculate air emissions. Assuming that a company uses 1,000 gallons of a chemical per year, we can find how much VOCs that company is generating. First, identify how much of its composition qualifies as a VOC in Section 3. This can be found by checking what percentage of the composition include volatile components that are under the VOC classification using the CAS numbers. Next, multiply the material usage, 1,000 gallons in this example, by the material density, which we calculated earlier, at 7.1767 pounds per US gallon. Convert it to tons by dividing by 2,000, then multiply by the percentage we found in Section 3 to get the total VOC emissions of 3.59 tons per year. A similar formula would be used when calculating HAP emissions. When businesses are looking to prevent pollution, an SDS is a great resource. Information provided in an SDS helps to inform decision-making when it comes to proper storage and handling, awareness of potential hazards, adherence to regulations, and identifying less hazardous chemicals to use. With a comprehensive understanding of SDSs, companies can respond promptly to accidents, recognize the human and environmental hazards, and ensure appropriate use of the chemical, all of which contribute to reduced pollution. As demonstrated, an SDS has valuable information that can be used to protect human and environmental health through pollution prevention. If you have any questions, you can contact the Pollution Prevention Institute at Kansas State University using the contact information shown on this page.